Alright, hello everyone. Welcome to the next part of your bonding. So previously we already learned about ionic bonds and also covalent bonds. So today we are going to look at the differences between the two types of bond. Alright, so it's going to be a short video today because we are just going to look at the comparison between ionic bond and covalent bond. Okay, this one is important. They normally like to ask or they normally like to compare between the two types of bonding. Okay, so it's basically like a summary of what we had learned in the earlier two parts. Okay, ionic bonds and also your covalent bonds. All right, so remember, ionic bonds is a bond formed between metals and non-metals. Okay, so this is the most basic one that you need to remember lah. All right, whereas for covalent bond, it is always between non-metal. Okay, whoopsie, non-metals. Okay, so this is the first difference between the two types of bonds. Alright, and then ionic bond, remember this one is about transfer of electron, right? So metal atom will release the electron. Okay, whereas the non-metal atoms, they are going to receive, right, or accept. Okay, so that is ionic bond. Okay, covalent bond, remember, is about sharing. Okay, so you need to remember the what they call key difference. This one is about, alright, electron transfer. Okay, transfer meaning one will donate, one will accept. Whereas this one is about sharing. Okay, so pairs of electrons are shared. Okay, by the same or different non-metal atoms. Okay, meaning your covalent bond, it can be between two same elements or two different elements. Alright, and then type of particle produced. This is important. Okay, sometimes students will always forget about this one. Alright, remember particles we learn atom, molecules, and ion. Three types. So metal atom forms positive ion. Okay, non-metal forms negative ions. Alright, and then remember I've been mentioning this a lot. Covalent bond will always form molecules. Okay, so we need to remember. Okay, covalent bond is molecules. Alright, how to predict formula. Okay, remember in the what you call chapter 3 you learn, right, about ions. Okay, you just cross the charges. Alright, so let's look at the electron arrangement. Okay, remember when they ask you to draw the electron arrangement, this is how you're supposed to draw it. Okay, for ions, must be bracket with the charge. Alright, and then it must be sandwiched between alternate ions. Okay, opposite ions. Positive, negative, positive. You cannot put positive, positive, negative. Okay, so you need to remember these two important things. Alright, and then in between ions is what we call the strong electrostatic forces. So during your explanation, you are going to use this a lot. Alright, okay, so for covalent bond, alright, is the one in the middle here. Okay, remember sharing of your electrons. Alright, so this is what we call strong covalent bonds. Okay, so you need to know how to draw the electron arrangement. Alright, so as you can see here, right, this one is slightly different from how I normally draw, right, but it's okay, it's acceptable. Okay, you either draw it like this, or if you draw it the way that we learn, alright, oops, okay, never mind lah, I'm just showing you an example. Or we put it in the middle like this, dot cross in the middle, in the space here also can. Or if you do it like this also can, it's acceptable. Okay, there's no right or wrong. Okay, just make sure that you draw it these two ways only, no other than that. Okay, alright. So examples, okay, of course you need to know examples of substances or compounds that is from ionic or covalent bonds. Alright, so ionic, there are a lot of what they call examples. Okay, the one that you learned in chapter 4, your periodic table. Alright, so the most classic example that you know, of course, sodium chloride, right? Okay, what else? We can also have what they call lead bromide. Okay, PbBr2. Okay, this is called lead bromide. Okay, lead 2 bromide. Okay, this is sodium chloride, lead bromide, and then you have a lot more actually. So if we say copper 2 sulfate, okay, this one the chemical formula will be CuSO4, right? And then there are many more lah. Okay, covalent compounds are your molecules. So molecules a lot, right? So one example is the one that you learned in Form 4, naphthalene. Remember naphthalene when we did the experiment? Okay, your C8H, oops, right? C8H10. Okay, naphthalene. Okay, the one that we did in our lab. All right. I'm referring to my students, my previous students. All right, the one that we did in our lab. All right, naphthalene. Okay, and then we have a lot more. For example, your methane. Okay, your methane gas. For example, this is your methane gas, right? CH4. All right, your carbon dioxide. Okay, and then many more. All right, so those are the differences between an ionic bond and a covalent bond. Okay, so you need to be able to identify, okay, the types of bonding. All right, so normally your job is to identify what kind of bond. Okay, in the exam they will give you all the unknown symbols and then everything. They will give you certain characteristics, and then from there you need to be able to deduce whether it's an ionic bond or a covalent bond. And then of course they will ask you the standard questions: draw the electron arrangement, write the chemical formula, so on and so forth. All right, so those are the differences between your ionic bond and also your covalent bond. All right, now this one is the physical properties. Okay, the differences in the physical properties of the two types of compound. Meaning if we say ionic compound and covalent compound, all right, what are the differences in terms of, like, for example, their melting and boiling point? Okay, so which one will have a higher melting point, which one will have a lower melting point? If you compare the two types of compound here, ionic and covalent, right? So remember that melting point and boiling point will always depend on the type of your bond or the type of forces that you have. Okay, so let's look at your ionic compound first. All right, this is sodium chloride. Okay, bracket. All right, I think there's a mistake here in your sodium chloride. Let me check the atom. 2, 8. All right, there's a mistake here. Okay. Oh, so sorry about this one. You shouldn't have a third shell here. Okay, this third shell shouldn't have third shell. It's only 2 shells only. All right, 2, 8, 1, right? So the sodium release 1 electron, so by right you only have 2 shells here. Okay, so please remove the third shell. All right. Okay, so positive and your negative. Okay, and then this is where the strong electrostatic force will appear. Okay, in between the ions. All right, so they are attracted towards each other because of this forces, strong electrostatic forces. Now, since this is a strong electrostatic force, meaning that you're going to need more energy to break the bonds, right? So if you're going to need more energy, meaning your melting and your boiling point will actually increase. Okay, so for ionic compound, they always have, all right, high melting and boiling points. All right, so and then if they ask you to explain why, then you say because the ions, all right, the positive and negative ions are attracted by strong electrostatic force. Okay, you see, we always use this term. Okay, explanation about melting and boiling point. This must be included in your answer for you to get the full marks. All right. Normally, students always leave out this particular part, or sometimes I've seen students writing strong force. They never mention electrostatic force. Okay, so you need to be specific. Okay, so if you have strong electrostatic force, meaning you're going to need a lot of energy to break it or to overcome it. Okay, so that is for ionic compound. All right, the melting and the boiling point. All right, so let's look at the electrical conductivity. Okay, so ionic compounds can conduct electricity, but with one condition: it must be in liquid form. Okay, meaning it must be in solution. In solid form, they cannot conduct electricity. If you don't believe me, you can do a very simple experiment. Alright, you try and connect your light bulb. If you have any light bulbs and then any wirings and anything, you can connect to a solid salt. Just take the salt from your kitchen, alright, attach to a battery, attach to your what they call a light bulb, see whether it will light up. Okay, and then you can do another one is that you dissolve the salt in water. Then you connect with the wires and battery and see whether your light bulb will light up. Alright, so basically ionic compounds can only conduct electricity when in liquid form. Okay, so they cannot conduct electricity in solid form. Alright, so basically they must be in what they call liquid, molten. Okay, yes, molten. Okay, molten or aqueous. Okay, aqueous meaning liquid lah. Alright, liquid can be two types lah. Molten or aqueous. Okay, the meaning of molten is, let's say you take your sugar. I'm sure a lot of people have done this before. You take your sugar, you heat it up, it becomes brown sugar, right? Okay, sticky liquid. Okay, that is what we can be considered as molten, meaning you heat the solid until it melts. That's the meaning of molten. Right, so in solid form, the ions are not free to move. Okay, why is it in liquid form we can conduct electricity? All right, it's because we need the free moving ions. Okay, we need free moving ions in order for electricity to be what we call conducted. All right, so in other words, if I give you a simple analogy, alright, let's say if I have a positive terminal here and a negative terminal here, and then in the middle, I must connect something, right, a conductor, right, in between the terminal so that the electricity can flow, right? And then remember, electricity is about the movement of electrons. So when you are solid, okay, the ions are not moving, alright? Therefore, it will be difficult for them to transfer the electrons. Okay, whereas is when you are what they call, if you have free moving ions, meaning the ions can move about, right? They are able to actually bring or what they call allow electrons to transfer. Okay, so how do they allow electrons to transfer? This one you are going to learn in your chapter 6, okay, your electrochemistry. Alright, so for now, you need to remember that ionic compound can only conduct electricity in liquid form, okay, or in aqueous solution. Alright, must be in liquid. And then if they ask you to explain why, because you have free moving ions. Okay, so that is the important point. Alright, solubility, salt, can you dissolve in water? Can, right? So most are soluble in water. Okay, and insoluble in organic solvent. What is organic solvent? Okay, so basically what they call covalent compounds, all right, that exist as liquid, we call them organic solvents. For example, your ethanol, meaning your disinfectant, the one that you're using every day, you spray on your hand every day to disinfect your hands, right? That is ethanol. Ethanol is an example of organic compound, not organic, covalent compound. Alright, but they exist as liquid, right? So we call them organic solvents. Okay, alright, so that is the important point about your ionic compound. Okay, so let's look at your covalent compounds. Alright, so covalent compounds, okay, you need to remember we have two things here. One is the covalent bond, which is this one. Okay, so you need to remember that this is covalent bond. Okay, the one in yellow. Alright, the one in blue, in between molecules, is the van der Waals forces. Alright, so type of forces, remember you need to know this. Alright, type of forces. Okay, if type of bond, this one is ionic bond, covalent bond. Type of force, this one is strong electrostatic force. Inside here is van der Waals forces. Okay, so you need to know the difference of the term that you are using right here. Alright, so basically van der Waals forces is between molecules. Okay, bond is between atoms. You see here, alright? Okay, so technically if this one I draw it in the simplified form, CO2, right? Okay, so this is one molecule of carbon dioxide. Okay, and then this is another molecule of carbon dioxide. Alright, inside one molecule inside we have covalent bond, and this covalent bond is always strong. Okay, between molecules, okay, between, remember between. So in between molecules is what we call the van der Waals forces. They are attracted by a van der Waals force. This one will always be weak. Okay, so melting point of a covalent compound depends on van der Waals forces and not the covalent bond. Okay, so you need to remember this thing. Alright, so melting point of covalent compounds, okay, is low. Why? Because of weak van der Waals forces. Alright, so for covalent compound, the van der Waals forces is the one that determines the melting and boiling point. Okay, since you are weak, meaning you don't need to use that much of energy. Okay, so you need less energy to overcome it. Therefore, your melting point, the amount of heat needed is lesser. Okay, but in covalent compounds we have two things lah. Normally we call it simple covalent molecules like this one, small molecules, or if we have another is what we call the very big covalent structure is what we call giant molecules. Okay, now in this case the giant molecules will have high melting and boiling points. Alright, because giant molecules, okay, you need to take note of this one, giant covalent molecules, they don't have van der Waals. Okay, since if you don't have van der Waals, meaning that you can only break the covalent bond in order to melt them. Alright. Okay, so that is the difference between a simple covalent molecule and a giant covalent molecule. Okay, a giant covalent molecule will be something like this, right? A very big structure. Okay, so in this particular case, right, uh, we can say that the what they call silicon dioxide itself is made of a very big molecule. Okay, one molecule is very huge. Okay, that's why we call it giant. Alright, whereas this one water molecule only like this. Oh sorry, this water molecule only like this. Okay, since they are super duper big, okay, basically the van der Waals forces is not really affecting their what they call it's not really being considered inside that. So we can say that they don't have van der Waals forces in giant molecules. Alright, therefore giant molecules have high melting and boiling points. Okay, simple molecules will have low melting points because of the van der Waals forces. Giant molecules, high melting points. Okay, so just remember the differences. Okay, covalent compounds will never ever be able to conduct electricity. Okay, and the reason why they cannot conduct electricity is because they don't have ions, right? No free moving ions, so cannot conduct electricity because they are made up of molecules, neutral molecules. Alright, so if you see here, this important part here, no free moving ions. Okay, doesn't matter whether in solid or liquid state. Alright, so in terms of solubility, okay, your covalent compound is the opposite of your ionic. Okay, they are not soluble in water, but soluble in organic solvents. Okay, alright, your alcohol. Okay, and then later on you're going to learn more organic solvents. Okay, alright, so that is the differences in terms of the physical properties of ionic bond and ionic compounds and also covalent compounds. Alright, now if we were to compare the strength of bonds, okay, if I were to compare the strength of bonds, okay, so which one is stronger than which one? Alright, so this is a general that you need to know, general thing that you need to know. Your ionic bonds will always be stronger than your covalent bonds. Alright, and then your covalent bond will be stronger than your van der Waals forces lah. Okay, so alright, so in this case, which one will have a higher melting point, which one will have a lower melting point? Of course, the ionic bond will have a higher melting point compared to covalent and your van der Waals. Alright, so we need to remember this one and this one is the one that determines the melting and boiling point. Alright, okay, except for giant molecules lah. If giant covalent compound, of course, is based on the covalent bond. Okay, but generally speaking, alright, if we talk about covalent molecules and also ionic compounds, okay, is generally based on these two lah. Okay, your ionic, of course, based on ionic bond lah. Alright, and then covalent is based on van der Waals forces. Okay, so you need to remember that ionic bond will have high melting point or boiling point. Whereas for your covalent compounds, they will always have low melting point and boiling point. Okay, that is if you compare between ionic bond and the van der Waals forces. Alright, so that is it. Okay, it's a very short video. Okay, just to show you the differences between an ionic compound and a covalent compound. Alright, so that is it for today. I'll see you again next time. Bye.